Okay, welcome to the Chapter 7, Section 1, Repetition, Definite Loops presentation lecture. As we get into repetition as a way of coding, we have worked very briefly with loops in the past. Repetition is something that is sometimes needed if you have particular code that is going to be executed on more than one occasion, or more than one occasion sequentially, or more than one occasion. It's going to happen once, then it's going to happen again, it's going to happen again, before the next set of code lines are going to be executed. In many kinds of animations, you'll see, especially simulations in games, some actions are going to happen over and over again. An example of this might be gallery games, where targets appear randomly on the screen and then disappear only to appear elsewhere, somewhere else in the scene. Now, of course, actions are made to happen again and again by running an animation, instruction, or a method more than once. Now, if we want Alice to execute a method more than once, we can utilize a loop control structure. Now, an example here is that a bunny is going to sneak into a garden and wants to eat a piece of broccoli. Now, the bunny will need to hop several times to get to the broccoli. So that hop method that is written has to execute more than once. So in this situation, what we could do is we could have the bunny hop method written like this. So bunny hop, simulates a hoppy motion, and then execute it 5 or 6 different times as listed in our method, calling upon it more than once. What we can do, we can call upon the method once and then incorporate a loop and just go ahead and set or dictate to Alice how many times we want that code to be executed. Now, what we can use is a counted loop. That's when we drag the loop control structure into our window, and then we can pull into it the method that we want to loop. Now, a counted loop is an alternative way to write repetitive code. It's going to repeat the instructions of counted number of times that we set it to do. So let's take a look at the example. When we take a look at the example, we'll get a better handle on exactly how these loops are going to work. All right, so here's the bunny. The bunny's going to hop. We have the bunny hop method written, and we want to loop it 8 times. So let's go ahead and play it and see what happens. Bunny hops over towards the broccoli. Now, if we want to take a look at the bunny hop code, this is the exact same code that we saw in the presentation. And now we're just taking this code, and we are going to loop it 8 times. So that code is going to go until 8 times is up, and then it's done. Okay. So the concept illustrated in this example is that the loop instruction is going to execute a definite, which means there's going to be an end to it, number of times specified by a count. Now, using a loop instruction is going to save time and can be very convenient for coders. Now, here's another demo. If we take a look at the Chapter 1, Lecture 1 carousel, which I'm going to show you in just a second, this is going to be an infinite repeat or infinite loop. Let's take a look and see what that looks like. Wrong one. We open up the correct world. Carousel. There we go. All right, so this one we have looping infinity times the carousel animation method is going to execute. So we hit play, and it just continually goes round and round and round. Infinite loop never stops until the program stops. A counted or a definite loop is going to execute a counted number of times. The concept illustrated here in this example is that infinity, if we select this, means that the loop is going to run until the program shuts down. That's what infinite knows. We know that from math class, what an infinite number is. Now, there's also more complicated loops. As we have code that is going to be repeated, we might have code that needs to be repeated inside of other repeated code. And it is also possible to place a loop statement within another loop statement and have nested loops. Now, this one is a Ferris wheel. So the Ferris wheel, the whole Ferris wheel is going to need to rotate clockwise, while the 2 inner wheels are going to rotate counterclockwise. We want this to happen at the same time. Now the inner wheels should perform 2 revolutions. For each outer loop, 1 revolution. Okay, that's an interesting problem to have. Now, how are we going to solve this? Let's take a look at the demo. Take a look at the demo and see what we have in store. All right, so this one we have, the loop is going to be 10 times. So the big loop is 10 and the nested loop is going to be 1. So for every 10 rotations, or how's this going to work? I'm trying to make sense of the code. This is going to go 10 times, then it's going to stop. For every big rotation of both Ferris wheels, each individual wheel is going to rotate twice. Let's play it and look. Once it does this 10 times, it'll stop. Always done. So there's a loop within inside of a loop. So nested loops for complex code that needs to be repeated, in this case, a rotating Ferris wheel. All right, so the concept illustrated here is that the inner loop runs completely each time, the outer loop runs once. The outer loop that executes 2 times and an inner loop that executes 5 times will actually execute the inner loop 10 times. Math involved here that we have to be made aware of as well when we are doing these nested loops. Another thing we can do here is we can actually use a function. A loop count can be computed by calling a function that returns a number value. That might help. And the loop instruction automatically then rounds the return value to the nearest whole number. So if we take a look at the next demo, which is the loop with function call, let's take a look at that one. All right, so now we have a loop where we're going to have the guy turn to face the girl. Then the loop is we're going to use the guy distance to girl to indicate when the code is to be executed and repeated. And then the guy is going to move forward 1 meter, and then the guy is going to walk and set walk equal to 1. So let's go ahead and play it and see what happens. Okay, so the guy's going to walk at the girl, and then once this function becomes true, the code's going to stop. So as long as the guy is not within the distance to the girl that is set, then he keeps walking until he gets there, and then the code will stop. So a conditional loop, I guess, is probably one way of putting it. You set a condition on the loop as to when the loop is going to stop executing. All right, so different ways of using loops. Loops, counted, infinite, nested, and functional or conditional loops are all the types of loops that you can use for repeating code. If you haven't already done so, please make sure that you read Chapter 7, Section 1 on loops, and then we will go through the in-class example in the next class period. And then after we are done with that, you'll be assigned your Chapter 7, Lecture 1 lab. All right, this concludes the Chapter 7, Section 1 presentation lecture. I will see you in the next class.